Hi everyone, welcome to this tutorial. We're going to be talking today about data visualization with Altair and also Vega and Vega-Lite, so hopefully everyone is in the right place here. So my name is Jake VanderPlas. I'm a longtime Python user, and I've contributed to a lot of the scientific Python stack. And I'm really excited to be able to tell you about this library. I've been developing it with a few other folks for the past year plus, and really in the last 4 months have thrown a lot of effort into this. And I'm excited about this approach to visualization and bringing it to the Python community. This is my first real kind of tutorial after I released the 2.0 version last week, so there hasn't been much time to give a tutorial before this, but it's good to have you here. So just to quickly motivate what I'm trying to do with this visualization library, I have a little bit of an introduction here. So for the first maybe 20 minutes of this tutorial, you can close your computers if you want and follow along. After that, I'm gonna start going into these notebooks that are at that address that I put up there before, and we'll get some chance to kind of put fingers on keyboards and try some things out, because you really learn by moving your fingers, not by just sitting and watching. So, but first. These slides are not available right now, but I will put them out and tweet them later after this. So to kind of motivate why I decided to spend all this time creating yet another visualization library in Python, I wanted to bring up some of the kind of basics of visualization. So one approach that to visualizing data that's been really influential is this book, The Grammar of Graphics. And the idea here is that when in the process of visualizing data, you start with the data, and then you have you transform the data. You have to figure out what marks represent the data. You figure out how to encode the essential pieces of the data into visual properties on the screen, whether that's X or Y, or the color of a point, or the size of a point. You figure out how those encodings will scale. Like if you want to encode the color of something, what sort of color map do you use? What sort of color scales do you use to encode that variable? And then once you have those scales, you need some sort of visual guide for the person looking at the visualization to figure out how that encoding maps to the data properties underneath. And thinking about data visualization in this way is really helpful, because it kind of boils down what you're doing, which is taking data and putting it onto the screen or onto the paper. It boils it down into the essential steps. And what Wilkinson did here is he created kind of what he called a grammar of graphics, a way of thinking about how you express these sorts of operations when you're creating a visualization of some data. And now, the thing that I've realized, and I've been using Python visualization tools for over a decade now, and the thing that I've realized is that where some tools go wrong is that it kind of brings your thinking away from this idea of grammar of graphics and what you're essentially doing with a visualization. And I really think this idea of visual concepts mapping directly to implementation is important. So you should be able to think about visualization in a principled way, and those thoughts should map directly onto what you type into your keyboard, and what you type into your keyboard should map directly onto what you see in the screen. And what I am really working on here is this idea that if you provide this implementation, this API that's based on these principles of visualization, then that API can help us develop the right way of thinking about visualization, which then kind of feeds back into creating good visualizations in the end. So this is one of the reasons that I was really excited about working on the Altair library. And just to compare with familiar tools that you've probably used, Matplotlib, I want to kind of contrast a little bit and let you see what it is I'm talking about in more concrete terms. So Matplotlib, if you haven't used it, it's this incredible package that I did my PhD in astrophysics, and every single paper that I published, every single plot in every single paper was made with Matplotlib. Like it's a phenomenal tool, and the reason it's phenomenal is because it's really straightforward. If you have an X array and a Y array and a color, and you want to scatter plot them and apply the color, you just say that. You do scatter X, Y, color, and you get the result. So really quickly, I don't want it to sound here like I'm ragging on Matplotlib. I really, really like Matplotlib, and it has some incredible strengths. Like, so for example, Matplotlib's API is designed like MATLAB, which, you know, you might like that or not, but if you look back at the history of scientific Python ecosystem, the fact that Matplotlib was an easy in for people using MATLAB is, I think, one of the big things that allowed this scientific Python to grow into what it is today. So Matplotlib had a big piece of that. Matplotlib has a ton of rendering backends. You can basically do anything, any system or any output, EPS, PDF, things like that with Matplotlib. It's flexible enough to basically produce any plot that you want if you put in a little bit of effort with it. And it's this well-tested, battle-tested tool for the last 15 years, and really, really active development too. So, you know, in a lot of ways, you can't go wrong with Matplotlib because it's this incredible tool that can do almost everything you want. The few weaknesses that I've been a bit frustrated by over the past few years is the imperative API, and I'll get into that a little bit, and the fact that it's difficult to go from Matplotlib and create a graph that's interactive on your web page, which is something that increasingly in the last 5 or 10 years, a lot of people have been wanting to do. So plotting with Matplotlib, like I said, is fairly simple. But if you start getting into statistical visualization and wanting to do a lot of data exploration with Matplotlib, it can get a little more complicated. So for example, here's the iris dataset, and say you wanted to plot petal length versus petal width and color it by species. You know, you can do that in Matplotlib, but it looks like this, right? You're starting by defining a color map. You have to do this group by in pandas to get the colors for each species thing. Blue, green, and red are the different species. And then you scatter each individual group. You know, all of this is really easy to understand as you're reading through it. But let's say you want to do something even more. Let's say you want to facet this, and you want to split the data into 3 panels, where the blue points are in one panel, the green are in the next, and the red are in the next. What you end up doing there is you have this, you're starting to mix together starting to mix together like the species names with the subplots and these axes, and you have to keep track of indices and make sure you're drawing the right axes and things like this. And so the fundamental challenge here is that we're mixing with the Matplotlib API. We're mixing the what and the how. We're mixing what we want to do with kind of the mechanics of how we're going to do it, drawing axes, drawing points, drawing plots. And so this is the divide that kind of motivates where Altair comes from. So Matplotlib is kind of this imperative mode of thinking. Specify how something should be done. Put a red circle here and a blue circle here. Whereas Altair is this declarative mode of thinking where you say what should be done rather than how it should be done. You want to map X to a position, map Y to a color. And so this is the key right here, and this is the strength in these declarative plotting tools that have become popular in some languages recently. So Altair was my attempt to answer this in Python, to say bringing declarative visualization into Python. And the cool thing about Altair is the grammar behind it is not something I had to come up with myself, which is why it's so good. Altair is based on these Vega and Vega-Lite grammars that come out of the Interactive Data Lab at University of Washington, and I'll chat about those a little bit later. But for right now, I just want you to see that this is kind of what an Altair plot looks like. If you take that iris data set, you tell it you want the mark to be a point. Then we have these encodings, right, where we're mapping X to the petal length, Y to the sepal width, color to the species. And then the scales, like the axis scales and the guides, like the axis labels and things like that, are all created automatically. So we get this scatter plot in a very easy to read declarative statement. And now if you want to do something like facet by splitting these points into different panels, you can just say, well, I want the column to be species as well. And it knows how to do that data transformation. It groups the data by the species, sends it to these subplots, and plots them up. So all of a sudden, you don't have to think about all the mechanics of what you're doing. You don't have to think about creating subplots and populating them. That's happening automatically based on this grammar. And the cool thing more recently in the Altair 2.0 release is that it has really nice APIs for interaction too. So if you want a plot that's interactive that you can publish on your website, you can add this interactive thing here and start scrolling and zooming. So this scratches all the itches that I've had when using other tools in Python over the last few years. So with that's the end of this slide deck. And what I want to do now is actually move over and show you a little bit of what it looks like to analyze data in Altair. Now you can open a notebook and type along with me now if you'd like, but at this point my goal is not to do something and have everyone run the code. My goal is to just sort of show you what a workflow will look like, to whet your appetite a little bit, and then in 15 minutes or so we'll start diving into a place where I'll move a little bit slower and more methodically through the concepts so that you can practice them along with me. Okay? So what I'm going to do right now is, how do I do a new notebook? I'm still figuring out JupyterLab. Let's see. I'm going to do it this way to make sure I get the right kernel. Ooh, did I use the wrong? I might have launched the wrong JupyterLab here. Let me double check that before I start doing something. I just need to make sure I'm using an environment where I actually have Altair loaded. I think I forgot to do that. Yeah. So I made sure that my JupyterLab works in this environment. And I'll cancel. And here's my new notebook. And sorry. There. Yeah, that looks better. Okay. So here we are. And if you want to start working with Altair, the first thing to do is import Altair as ALT. And we'll need some data to work with as well. So let's, I put together this package called, from Vega Datasets, import data. So I put together this package called Vega Datasets that just has a bunch of sample datasets that are good for Vega and Vega-Lite and Altair. And this one in particular that's fun to work with is the cars data. So let's look at this data set. So this is typical of the kind of data that we're going to work with in Altair. It's a tabular data set. It has columns that are observations. It has rows that are single entities. So each row here corresponds to a car. And the columns are recorded variables about each of those cars. Now, if you want to visualize this in Altair, the basic thing you do is create a chart with that car's data. And we need to choose a mark. So here I want to do mark points. And let's take a look at what that looks like. All right, so this is your first Altair visualization. And what that is, if you can't see it, there's 400 cars in this data set, and it has drawn 400 points on the screen right on top of each other, one for each car. So it's a visualization, but it's not very useful, right? What we need to make this a little bit more useful is we need to add some encodings. And so what encodings are is basically a way to map visual elements of the chart, like the x-axis, the y-axis, the color, onto columns of the data set, and you reference the columns by name. So for example, we might want X to be horsepower. Actually, let's do miles per gallon. So I think I misspelled this right here. It needs a capital. So there we've actually taken the points and we've spread them out along the axis. We've encoded them with information from the data set. And we can start to do things if we want to do something different here. Maybe a tick mark might be better. So we get tick marks there, and but there's an issue with this visualization, right? We have a lot of things on top of each other, and it's sort of hard to see where things fit in there. So let's go back to doing mark point, and instead of just plotting the x, let's also do the y equals, say, horsepower. So now we've said we want to encode the horsepower variable into the y-axis, and we get a scatter plot like that, right? So this is the way to kind of like grammatically think about your chart. You're creating a chart with data, you're choosing a mark, and then you're encoding visual aspects of the chart onto elements of the data set. And like I mentioned before, if you want to have an interactive chart, you can add an .interactive method at the end. I'm going to make this a little bigger. And then you get the ability to, oh shoot. This was happening before with I had JupyterLab issues for some reason. The interactivity is not working. Oh no. I might have to come back and figure out how to fix that. This. Yeah, so this happened to me a few days ago, and the way I fixed it was reinstalling JupyterLab. So I don't know if I want to do that right now. Yeah, let me. I'm gonna save this. I'm gonna close that. Sorry, this is the joy of live coding, right? I'm gonna try something different here. Source. So really quickly, what I'm doing is I'm changing to a different conda environment, and I'm going to really quickly conda install -c conda forge Jupyter Lab Vega Datasets Altair. So this is what I ask you to do in the email. And I'm going to see what happens if I try to do this right now. So this is one of the things that with Altair that's a little bit difficult right now, is that essentially under the hood what it's doing is it's when you create a chart like this, it is on the Python side, what it does is it takes this chart spec and it outputs a Vega-Lite grammar. And what a Vega-Lite grammar looks like, I have this way down here in kind of my extra notes. When you have something that looks like an Altair chart, what that's doing is it's producing this JSON specification that this JSON specification of the data, and that is the thing that's then read by the JavaScript library. This is a Vega-Lite specification, and then the output of the Vega-Lite is kind of this more sophisticated grammar called Vega. And Vega is this really, really complicated thing that's happening under the hood. And the Vega is what is fed into the renderer in order to visualize the plot. And that's basically on top of Vega Vega sits on top of D3, which is something that you might have used before. So that's how the interactions happen. So what's going on in executing transaction? Hey, it downloaded. Now it's just installing things. Cool. I hope it actually works. Yeah. So what's going on then when you create an Altair plot, and this is why you need JupyterLab or Jupyter Notebook set up correctly. JupyterLab and Jupyter Notebook know how to interpret that Altair output, convert it into a Vega-Lite specification, feed that Vega-Lite specification to the browser, and then use JavaScript to render that Vega-Lite specification in an interactive graph. So sometimes we're still working out the kinks in that whole workflow, and that's why some of you have had some installation problems and why I had some installation problems live on stage right here. that's something that it's gotten a whole lot better in the last couple months, and as we continue working on this library, I think it will get even better. So let's try this again. I'm going to get a default launcher, and actually I can probably open Untitled 3, which is the one I was working on. You can tell this is a relatively new directory for me because it only goes up to Untitled 3. Yeah, so does this interact? Yeah, all right. So there's something weird was happening with my Jupyter extension where it wasn't actually registering the clicks on the page in order to do that. So I'm sort of glad this came up because it shows you that there are some hiccups with the system right now, but you can generally get around them if you work on it. Okay, so we got our interactive plot, right? We're doing alt.chart/.interactive, and then you can visualize this. So just to show you exactly what's going on under the hood here, if I do .toDict, this is the routine that will take my Altair chart and output this Vega-Lite schema. You can see that it's saying it's a Vega-Lite schema JSON object, and the config this is the view and the height, and then the data here is actually all the values of that pandas data frame just dumped into JSON. So just to make it a little bit easier to see what's going on, I'm gonna create a smaller data set called cars1 equals cars.iloc:1. So that's just a way of saying like take the first row of the cars. And so just for the sake of doing toDict, you can see here is the first row of the data that has all the values. And then in here is the encoding, the X is the miles per gallon, and it's called it a quantitative type. Y is horsepower, it's also a quantitative type. The mark is a point, and this selection right here, this is what binds the scales. So we've bound the scales of the selection to the X and Y, and that's what makes it so that you can scroll around here. And here's my 1 point. Let's do all the points again. Yeah, that's a good question. So the question was, can you take this dict and modify it and then get a chart out? And that round trip is available. So like if I say spec equals this, I can do alt.chart.fromDict spec, and then it returns returns a chart object that renders that spec right there. So what that means is that if you find any Vega-Lite visualization online, you can copy that JSON, you can import the JSON, turn it into a dictionary, and then load it into a chart, and then you can start doing things like encode color equals origin. So I thought you could do that. Did I do something wrong? Oh yeah. I need to specify that the origin is a nominal type. We'll get into what that is later. So this makes it really flexible, and since Vega-Lite is it's starting to become like a standard tool used around the web. Like for example, Wikipedia understands Vega-Lite specs and can render them on Wikipedia pages. So if you want to put an interactive graph into a Wikipedia page, you can do that via Vega-Lite, which is basically all the output of Altair right here. So this is a format that's starting to be used pretty widely on the web, and I think it's really powerful to be able to ingest that into Python and start working with it directly. Okay, so the question was, can you do the same thing at the D3 level? That gets a little more complicated, but the answer is still yes. And the way that you do that is something called a Vega view. So we'll see how well Google is working in this room. So if you look up Vega view on Google, the view API of Vega is like the JavaScript side tools that once an Altair plot is rendered, if you have access to the JavaScript environment it's rendered in, you can start messing with the plot from that side and using D3 style tools to do things with that. So it's a nice stack, I think. Perry in the back. Yeah, so the question was, is there a way to get this output into publication quality PDFs? Right now you can do things like save chart.svg. So it'll save something was imported. Oh yeah, I didn't. You need the Selenium package to do that programmatically. But if you want to do it really easily from the web interface, you can just click Export PNG right here. So we have a way to export PNG and a way to export SVG. And since SVG is a vector graphic, that can be converted with external tools into PDF. It's something on the roadmap. I'd love to be able to do .save, save something .pdf and just get it right there. But yeah, you can do that. I saw another question right here. Yeah. Oh yeah, so the question is, I didn't specify what kind of plot I wanted to make. And in this case, actually I did, right? Because I told it that I want mark point. Now I could very easily do mark line, and it would try to draw a line between all these. I could do mark bar. Bar is a little bit weird here because you usually want to bin things, and that's a great segue because I'm going to talk about binning right now. So if we take this basic chart with a bar chart, I'm going to scroll down here and start. I have a stray dot. We have this bar chart right here. Let's go back to just looking at x equals miles per gallon. So this is not a very interesting chart. Maybe we can go back to using our tick marks. So we have this 1D chart right here. Something that's really useful in data visualization is binning things to make histograms or other types of plots. So if we want to bin data, we can start with this alt.x as a way to pass more arguments to the x encoding. And we can just say we want bin equals true. And then what we get is a binned version of this data. So all the data points, you can see some of these ticks are darker than the others because there's more data points in here. Again, this is not a very interesting visualization, but if we go on the y-axis and say the y should be the count, a little function in a string right there, then we get tick marks that reflect the count in each dimension. And it's a little bit hard to see, so instead of ticks, let's call this a mark bar. And we got a histogram right there. So the cool thing about this is that things like histograms and binned heat maps and stuff like that are not special functions by themselves. You don't have to do Altair.histogram. Those are visualizations that arise naturally out of this grammatical form. If you can bin one value and you do the count and the y value, then you can get a histogram. And if you want a 2D histogram, we could do, like, for example, y equals alt dot y horsepower bin equals true. And we can do instead the color equals count. What did I forget? I forgot a comma. So now all of a sudden we have a heat map of the data with this binned inputs. And you don't have to remember, the syntax of an Altair.heatmap function. You just remember these declarative building blocks that let you build up the chart from scratch. And that's sort of the key idea behind these declarative grammars is that if you're given these building blocks of data transformations like binning, or data aggregations like counts, or encodings like x, y, and color, then what you end up with is the ability to very quickly build up sophisticated visualizations without having to memorize functions in an API. So I want to go back really quickly to one more thing in this live demo that I think you'll really like. Where did my scatter plot go? I totally lost my scatter plot. That's all right. We'll recreate it. It's only a few lines of code. So we want y as horsepower, and we want color equals origin. So, and I don't want mark bar. I want mark point. Yeah, so given this scatter plot, we were able to make it interactive, but the other killer feature of Altair that I really like is there's this grammar of interaction that allows you to, just like how we built up the plot from basic building blocks that we can put together and end up with an interesting visualization, there's a grammar of interaction that allows you to build up interactive features of the plot from these sorts of components. So I want to give you an example of this. If we do interval, we're going to make an interval selection. And I'll do alt.selection_interval. And I'm just going to add this to the chart right here. So the chart has this way to say properties. I want to add some properties to the chart. And I'm going to make selection equals interval. Okay, so what did this do? An interval selection is a way that you go to a chart and you click and drag and you create a box that you can move around. So the interval selection can be in 2 dimensions. We can say encodings equals x, and then we get an interval selection in 1 dimension that we can move back and forth. Encodings equals y, does an interval, in the y selection. And you're saying, well, this is great, Jake, but what am I going to do with that? So you have this box that moves around. And now the interesting thing you can do now is once you have this selection, every time you move this around, there's a signal happening in the renderer that's saying the selection has changed and these are the points that are in the selection. And where things get really interesting is if you start making properties of the chart conditional on the selection. So let's say we want the color to be conditional on the interval. And if it's inside the interval, we want the color to reflect the origin. If it's outside, we want the color to be a value that we'll call light gray. And the reason you need alt.value here is because otherwise it would interpret light gray as a column name. So we want to specify that this is actually a color name. So you do that, and now all of a sudden you can click around, and the points inside the selection are the origin color, and the points outside the selection are light gray. So I love this because I don't know, I'm sure I could do this in Matplotlib, but it would take me reading 4 tutorials in an afternoon. But in Altair, you can do this in a few lines of code, and it gets even better. I'm going to show you this. This is super cool. So one thing that Altair does is if we say this is our chart. If you want to do multi-panel charts, there are a few little shortcut operators, and we'll go into these in more depth later. But if you do chart with a little vertical bar and a chart, what do you think that does? What would you imagine that does? I don't know. Maybe sticks them next to each other. Yeah, you're right. So now we have 2 versions of this chart side by side, and the selection between them is linked. So because they both have that selection tied to them, they know about this. And now all of a sudden you might think to yourself hey, I could make some interesting visualizations on this. So what if this second chart I encode x equals, say, acceleration? Now we have 2 different views of the data, horsepower on the y-axis, miles per gallon, and acceleration. And we can see how these are related, right? It's it's pulling out the, wow, thank you. So, in a few lines of code, and this is what I mean by building blocks of selection. You're not having to write a lot of JavaScript to do this. If you can just understand the declarative building blocks, it lets you start to explore things. And what I really like here is if you do just the encodings in the x direction, then it automatically shows you about some of the relationships here. As I go from left to right on miles per gallon, it's going from top to bottom on horsepower. Right, and you could get that a little bit from the static plot, but it's nice to be able to do these automatically. And you can do other interactions too, like if you want the tooltip, and let's say tooltip equals, I forgot the name of it. Name. Tooltip equals the name of the car. So now, if we're interested in what any point is, we can get the name of the car just by hovering over it. So this lets you, what did I do here? This is 10 lines of code. 10 lines of code for a linked brush across a multi-panel scatter plot with tooltips. I don't know, I kind of like that. So, yeah. Oh yeah, that's weird. I think that might be, that's interesting. I think that might be due to some Z order in the visualization. Yeah. Oh yeah, over here it works. Interesting. Yeah, I hadn't noticed that before. You should raise a bug on the Vega-Lite issue tracker. They might say, that's just too hard to fix. Yeah, so that's a the question was, is there a way to interact with the selection data outside the chart? And the answer is, right now, sort of. You can interact with it in JavaScript. So if you go to your JavaScript console and you start typing the right things, you can interact with the view object and get the selection data and things like that. We haven't gotten a coherent story yet for interacting with that selection data from Python. It's a little bit of a complicated thing because we have this like front end versus back end model. Currently, we're passing messages from the Python back end to the JavaScript front end, and doing that message passing the other way is possible, but it gets a little more complicated. So that's something that I'd like to work on in the next, in the coming months, as we continue to improve the package. So right now, the visualizations you produce in Altair are purely client side. We're not doing anything interacting with the Python kernel. It's all happening in the JavaScript on your browser window, which means that you can take a chart like this and you can do .save mychart.html, and then if I say open mychart, I think it's in notebooks, mychart.html, then you have a standalone web page that why is it resolving host? Anyway, if the network wouldn't be so slow. Right now, the reason it's holding up is because it's trying to load the Vega and Vega-Lite libraries from the web, and the web is not working. Yeah. So anyway, you have a standalone HTML document, which means you can take these charts and you can use them in a variety of formats, and you don't have to worry about being connected to the Python kernel. So that's a nice thing there. Okay, so anyway, this is sort of my man. I'm glad the internet was working when I had to reinstall JupyterLab. That would have been bad. So that's the basic like live demo of how when I'm using this library to plot things, I sort of work and explore data and start to add these interactions. I did want to show you one more demo because this gets really cool. There's some really sophisticated things you can do with selections. So if I take this chart again, and let's say I have another chart that I want to make like a histogram equals alt.chart cars.mark. I'm going to do a bar marking, and I'm going to do a sideways histogram. So x is going to be the count. Y equals origin, and color equals origin. And I just said his, so I got to evaluate that. So this is a nice little sideways histogram showing you that there's a lot more cars from the USA in this data set. If I do a chart with an AND operator in hist, does anyone have guesses what this would be? The vertical line was stacked sideways. The AND is stacked vertically. If you can't remember that, you can also do alt.vconcat, which is a vertical concatenation of two charts, and that does the same thing. So we're stacking these vertically, and we have this that we're doing here. We can do other things with selections too. Like for example, if I want here, I'm going to do a transform underscore filter. And I'm going to filter by, what did I call this? Interval. So now you have a data set where the selection is reflected underneath in the bar chart, right? Because we're filtering the data that's shown in the lower chart by the contents of the selection in the upper chart. So I don't know, I like this. I don't know how I would do this otherwise. I would spend 2 days reminding myself how to write D3. But like I said, this is kind of the power of Altair is these building blocks that let you do all of this stuff. Yeah, sorry about that. We'll get into some better code, some more. We'll get into a place where this code is actually written down in front of you in the notebook instead of me just typing it. And so from here, having kind of finished this demo, what I want to do for now is go into this index right here and kind of start walking through the outline. So if you want to know the rough things that I was hoping to remember to do in this live demo, you can click on this 01 cars demo, and it has probably everything that I did there along with some explanation of what's going on in it. So if you want to refer back, that's a place you can do it. But from here, I just want to give you a little bit of the outline. It is, let's see, it's 2 o'clock right now, so we're 40 minutes in, and we have a break at 3 o'clock. So for the next hour, what I want to do is dive into the central concepts of creating a simple chart. So I breezed over them in the live demo, but we're going to go in a little more depth on some of these core concepts here. The binning and aggregation, the layering and concatenation, and then hopefully before the break at 3 o'clock, we'll have a chance for you to explore a data set and try making some of these simple charts. Once we come back from the break in the afternoon, then we'll get into some of the more advanced things, like all the different building blocks of selections and what you can do with them to make these interactive charts. Things like transformations to more sophisticated things you can do beyond just binning and aggregation for your data. Configuration of your charts, if you want to adjust the titles and tick marks and axes limits and things like that. And then a little bit on geographic charts. We may not get to that. And then at the end, if we have some more time, I'll give you a chance to kind of apply those things to the data sets that you're working with. So now is the time that hopefully, if you have downloaded the if you've downloaded this material that I put up, where was it, in the index? Yeah. If you've downloaded the material from here before the internet stopped working, then you can follow along inside the notebooks. Otherwise, you can follow along with a new notebook that you've opened up. And I wanted to say one thing as we're starting to type here. We have some volunteers in the back who've, if you could raise your hands. These are friendly folks who have volunteered to be here and help with any technical issues. So if you get to the point like I did where things just don't work in JupyterLab and you need some help, feel free to raise your hand and catch one of them, make eye contact with one of them and they'll come and help you out. Because I really want you to be able to code along with this as we're going. All right? Anyone having installation issues right now? Yeah. There was one question, I missed that. Did someone say something? Yeah, the materials are all on this website right here, github.com/altair-viz/altair-tutorial. And hopefully the web works. No, the web doesn't work. Yeah, sorry. Yeah. github.com altair-viz/altair-tutorial. Yeah, question? Yeah, so the question was, is this library similar to Plotly? It has some similarities and it has some differences, obviously. So the way that Plotly is the same is that it's a Python interface that creates a JSON grammar that's then visualized by a JavaScript library. The thing that I like about Altair over, actually I should say Bokeh is similar as well. It produces a JSON plot spec that's visualized by a JavaScript library. The thing that I like about Altair is that the JSON spec itself was actually designed to be human consumable and human usable. So the JSON spec kind of encodes that whole grammar of visualization. And in the Plotly version and in the Bokeh version, and also, did anyone ever use MPLD3? This is this library I made a few years ago that MPLD3 was similar in that it's a Python library that creates the JSON spec that's visualized by a JavaScript library. In all those cases, the JSON spec is not designed to be human consumable, and it's not designed on grammatical principles. It's designed on imperative principles. And so the difference here with Altair is that it's kind of like grammar of visualization from the ground up, including the encoding of your chart. Yeah. Mm-hmm. Yeah. Yeah, so the question, if you didn't hear it, was about what does it look like to host this elsewhere? And if you look in this this HTML file that was generated here, I can never remember how to change the size in Emacs. Is it Control plus? Command plus? No, it doesn't work. Well, anyway, I can just show you that essentially what it is here's a CSS block that's just kind of deciding on margins and things like that. Here's loading Vega and Vega-Lite and Vega Embed. And then there's the actual spec that's just embedded in the web page. That can be loaded from file as well if you want to do it that way. And if I scroll all the way down, if it lets me do that, right here is where the JavaScript code. Oh, geez, why is it? It's hanging. Emacs is supposed to be like performant, right? Here's the JavaScript code where you are taking basically right here, this is a Vega embed call that in one line of JavaScript takes that JSON spec and puts it in a div in your web page. So it makes it really easy to, as long as you have a web page with JavaScript, you can embed that anywhere. And then, yeah, the interaction and the tooltips and everything. Right, yeah, so this grammar contains all the interaction, and then the JavaScript library knows how to render that. Okay. Come on, yes. All right. So let's take a look at this, going to the number 2 notebook, Simple Charts. So basically this is just walking through, I'm gonna clear all outputs so that I actually remember to execute things along the way. This is just walking through the central things that you should think about when you're creating a basic chart, like a basic line plot or a basic scatter plot. And going back to this grammar of graphics idea, you have to think about your data, your marks, and your encodings. Remember, the data is usually a tabular data set. The mark is how you want that data to be represented. And the encodings are the way that you map visual features of the chart onto columns in your data set. The other thing that I glossed over before is this idea of encoding types. And we'll get into that. And then the binning and aggregation. So these are what I think of as the central pieces of creating a single panel Altair chart. We start by importing Altair's ALT, and one thing is, because the rendering happens in JavaScript, if you're using the classic notebook rather than JupyterLab, you'll need to run this renderers.enable notebook. And if you're using another front end like Colab, there's also a Colab renderer that you can use, things like this. Do you have a question? So if you're having trouble with Wi-Fi, you have what? Oh, the notebook's on a thumb drive. All right, thanks so much for that. So yeah, so as I mentioned, the basic Altair chart is this pattern that you should get really familiar with. Is you make a chart, you give it some data, you specify the mark, and you specify the encodings. And like I mentioned with the data should be a tabular format. So each row of the data set corresponds to an object that you're observing. Each column of the data set corresponds to an observation or a feature of that object. If you've done any machine learning with scikit-learn or anything like that, this probably seems really familiar because this is exactly how data is encoded for those sorts of machine learning tasks. The chart object itself, of course I didn't run this. I didn't import Altair. The chart object itself is something, it's basically a thing that knows how to emit a JSON dictionary. So, and the other thing that it'll do is it will, if I do chart.toDict, actually I'll run it down here. If I know chart.toDict, it not only knows how to render a JSON dictionary, it also knows how to validate that JSON dictionary. So here, if I just do chart.cars.toDict, it'll give me the schema validation error. And so what that's saying, and if you read down here, it'll say mark is a required property. So this is something that comes from Vega-Lite itself. Vega-Lite, if you try to give it a chart without mark set, it will raise an error for you. And because errors in JavaScript are kind of hard to deal with, we try to catch those errors in Python if we can, so that you can use Python's traceback mechanisms to do that. So a chart with just a data set is not a valid chart, but a chart with a mark is a valid chart. And this is going back to that very simple 400 points stacked on top of each other chart that we saw before. Now if we do this alt.chartMark.toDict, again, we see that this is this Vega-Lite output. And this Vega-Lite output is what gets read by the JavaScript library and encoded and visualized, etc. And now we've seen mark point, but there are a number of different mark objects you can do, or mark methods. We have, in Altair, there's point, there's circle, square, whoops, I double-clicked, square, line, area, bar, tick. And if you want to see all the available methods for the mark, we've set it up so if you do alt.mark and then press the tab key in JupyterLab, you get this tab completion menu that shows you all the marks that are available. And some of these are a little more obscure, like geoshape is used for geographic shape markers. Trail is kind of like a line that can vary in width along the length of the line. So those are the marks. And now next is the encodings. So again, if you, we've seen that if you do something like y equals origin, it will take those points and spread them out along that y encoding. And there are a number of encodings that are available. They're like, well, x is the x-axis, y is the y-axis value. I keep double-clicking. There's color, there's opacity, there's shape, there's size, and row and column are used for faceting charts. So by mixing and matching all those encodings, you can make a huge number of very simple charts from a data set. So I did y equals origin here. I could do x equals counts, for example. I forgot a comma because it's Python. So we do y equals origin, x equals count, and maybe instead of a point, I want to mark bar, and maybe I want to do a stacked bar chart where the color equals the cylinders. So now you see that there are between 3 and 6 cylinders, and you can see the relative proportion of the cylinders in the chart. Yeah, back there. List of aggregates. Yeah, good question. So aggregates right now are like you said, just within strings like this, and there is a list of aggregates on the Altair website, which let's see if I can get in there. Yeah, cool. So there's somewhere binning. Compound charts, top, lower marks, data transformations. I thought there was a binning reference in here. Let's do aggregates. So this is one of those things, somewhere in here, data transformations, that's it. Aggregate transforms. Well, obviously, since I can't find it, I should actually make the documentation a little easier to search. Okay, here's a list of them. There's this section on encodings, and then binning and aggregates is down in the bottom. Yeah. So it's under user guide encodings, binning and aggregation down here. And if you go to that, you can see the list of all the aggregates here. Now there's been some discussion about turning these into actual functions, so you don't have to, write the open-close parentheses within the strings. That's just a design decision we made early on. I'm sort of the mindset that we should turn them into functions so we can get tab completion on things. Some of my collaborators feel a little iffy on that for various reasons, but it's one of these design decisions that's going on. But if you feel very strongly about that, you should weigh in on the GitHub issue. But yeah, so there's a whole bunch of different aggregates, things like argmin, argmax, median, mode, quartiles, confidence intervals, and we'll see a few of these later. So there's a bunch of different options. Okay, so going back to this is we've seen these essential pieces: the data set, the marks, the encodings, um, and I think I just kind of like skipped over all these different things you can do. But essentially, once you start combining all those pieces together, you can create a huge variety of charts. So right now, I want to give you a chance to do this a little bit, to try these things out. So take this data set, this cars data set, and try making some plots. Use mark point, line, bar, text, rect. Use different columns and figure out what you can visualize in the data. Use different encodings mapped to those columns. And in particular, I want you to think about, as you do this, which encodings seem to work well with continuous data, which encodings go well with discrete or categorical data. And as you make these charts and try things out, see how that goes and see if you can come up with some sort of general rules about how you would think about visualizing different data types. So I'll give you about 10 minutes to start doing this. And it's always fun to work with a partner. So if you look to the person next to you or to a group of 3 around you, maybe you can all lean in on one laptop and sort of make some decisions about what you want to plot. And if you have questions while you're doing this, raise your hand and I'll be walking around and our volunteers in the back will be walking around as well. Okay, I'll call us back together in about 10 minutes. Right. So hopefully you had a chance to play around a little bit. Did anybody come up with like a really cool visualization that you think people should see? And nobody wants to volunteer. That's cool. We'll have a chance to come back to these things later. So one thing I haven't talked about in this data model, or I've touched on a little bit, but we need to talk a little bit about, is this idea of encoding types. So fundamentally in data visualization, people have been thinking about this idea of encoding types going back 50 years. I think there was a paper back in 1967 that where this scheme was concocted. So the idea is that if you have some data that's quantitative, that's like real valued and continuous, something like miles per gallon, that can be any number between 0 and as high as you can go, right? There's some values that are nominal. So nominal means something that's a name or a category. So it's an unordered category. So like in the cars example, the country, USA versus Japan versus Europe, country or continent is an unordered categorical. There's no fundamental order to those. Then there's categorical values that are ordered, like say the number of cylinders. You can't have 1.37 cylinders in your car. You have 1 or 2 or 3 or 4 or 5, right? So this is an ordered category. And then temporal is kind of similar to a quantitative, but it knows a little bit about dates and things like that. So when you're thinking about visualizing data, it can be really useful to think about the type of data that you have and the types of encodings that are better to use in each of those situations. Now, if I click back over here, I put this. I'll put all this online later. But this is the publication that I was referring to in 1967, Burton's Semiology of Graphics, where basically it's written in French, so I think there are English translations out there. But basically he started thinking about like how you encode data on a page, because they didn't really have screens. Well, it had some screens, but how you encode data in 2D. You can start thinking about like position and size and the opacity or the value of the color. You can start thinking about things like texture or the hue of the color or the angle of the mark or the shape of the mark. And over the past 50 years, people have done a lot of work into figuring out how to best use these potential encodings to figure out, to best represent data on the screen. And in general, there are things that inherently have some sort of order to them. Like for example, XY position. We always know that there's things on the left and there's things on the right and there's things in between left and right. I'm looking the other way, so things on the left and things on the right. There's size, right? So size, something is small, something is big, and something is in between. Color value, you can do that to an extent. Something is brighter or darker, right? But then there are things that are not so. I actually have these all here. Cool. And there are things that are not and that don't have a fundamental order to them, right? Like color hue. If you have blue versus red versus green versus yellow, this doesn't convey a sense of order to you, right? So it would be kind of silly to encode a quantitative value, something that's real valued, with color hue. It's okay to do real valued with color value, because there's some sort of way that you can say this is lighter than that, and this. But one thing that you might notice is that it's way easier to figure out between these points whether something is bigger or smaller. Whereas with color value, it's a little harder. You have to think a little bit more about how to order these 4 points in order to get them in the right order, right? So essentially, 2D position and size are really, really good for encoding quantitative values. And position is actually the best of all. That's something that we can just look at and process without having to think. And as you go to like color hue, it gets a little bit harder to encode order. And when you go to, or sorry, color value, when you go to color hue, the order disappears completely. And so Burton had this thing called levels of organization, where when you're encoding data, you start thinking about, well, position is really good for nominal, ordinal, and quantitative data. Size is very good for nominal, ordinal, and quantitative. But as you go down, things like angle, it's really hard to look at the angle of a plot and like immediately see an order in those angles. You can do it if you think really hard about it, but it's not a great way to encode quantitative, real valued information. So going back to that thing, so we want our plotting language to map onto these ideas of what the best way to think about graphics is, right? And so going back to our demonstration, I think I need to escape this. Going back to our notebook, these quantitative, nominal, ordinal, and temporal values are built into the basic API of Altair. So for example, here, if I plot this, I'm plotting x equals miles per gallon, y equals origin, color equals cylinders. What would you say what type is the miles per gallon? Is it quantitative, ordinal, or nominal? Yeah, quantitative. So just to be clear here, we can in Altair we can add this :q to the end of the to the end of the quantity, and it'll automatically give us the right quantity here. Now, origin, should this be quantitative or nominal or ordinal? Nominal, yeah, because it's a name. It's an unordered category. So we can add that there. And you can see that these are not changing anything because these types are inferred by Altair when you pass it a data frame, because it can look at the values and say, these look like numbers, so we should make it quantitative. Now this one is interesting. Cylinders, should this be quantitative or nominal or ordinal? Ordinal. Yeah, so this should be ordinal. And right now, you can see that cylinders is encoded with this continuous color bar. So Altair looked at this and said that cylinders is numbers, so we're going to treat it as a quantity. But it's much better if we treat it as an ordered category. And then even if you treat it as an ordered category, the renderer knows how to visualize that legend in a way that makes a little bit more sense. Right, so just to show you, if you do quantity like that, it'll be a continuous legend. If you do ordinal, it'll be a discrete legend. And then if we decide that this is nominal and no longer has an order, it'll choose a color bar that doesn't have any inherent sense of order. So that's not necessarily the best thing to do in this case. Yeah, no 7-cylinder cars, and that's harder to see in the other. Well, I guess you can see it here. Yeah, why don't they make cars 7 cylinders? I don't know. Symmetry. But there's 5 cylinders. So anyway, as you make your plots, like I said, these sorts of quantities these data types are inferred automatically when you pass a data frame. But it's good to get in the habit in Altair of explicitly thinking about these and setting them. And the ones you need to think about are Q for quantitative, N for nominal, O for ordinal, and then the T is a temporal type if you have dates. Yeah, question? Yeah. So if you make this an N for nominal, then it treats it as an unordered category and creates an unordered color map. And if you do O for ordinal, then it'll treat it as an ordered color map. And if I do Q for quantity, it treats it as a real valued function rather than a categorical. So it's nice to be able to switch between those types of things. And this has been one of my frustrations working with other Python tools, is that like doing this sort of legend versus a color bar legend is like a fundamentally different set of functions that you have to call, right? And it's nice to have the symmetry of this in the grammatical API. I saw a question back there. Someone? Oh yeah. Yeah, good question. So the question is, how does the algorithm identify a time variable? So Pandas has this datetime64 type, and it will if you pass a data frame with a datetime64 typed column, then Altair will assign that to a temporal variable. But if you just specify a time type, then the Vega-Lite engine will try to interpret the column as a time, even if it's just like ISO encoded strings or something like that. So yeah, so if you have a column named year that is of a numerical type, then by default Altair will treat that as a numerical type because it doesn't try to parse the meaning of the column names, it just tries to parse the type of the data. So if you want to specify that a column should be temporal, then you should use the T marker for it. And so for example, this miles per gallon, I could call that temporal. And what it does is it converts the numbers into Unix timestamps. So it gives us seconds since, what is it, like seconds since 1970, January 1st, or whatever it is like that. So when you tell Altair what to do and what kind of type you have, it'll try to do the best thing with it, but it knows how to do that. Yeah, so Altair, when you pass a pandas data frame to an Altair chart, that's where it'll do that inference based on the types of the columns. But for example, you can do a URL. So if I do data.cars.url, so this is a URL of where this data set lives online. I can do stick a URL there for the data set, and it will, assuming it can download the data. I think we lost web connection again. But if it can download the data, it'll actually visualize that. But if you pass it a URL and you don't give it the data type, Altair has no way to infer that data type. It can only infer the data types for pandas input. So this is one reason it's nice to get into the habit of actually doing things, adding these all the time. So I'm not sure. I think this is not rendering because it's getting a URL error. Oh yeah, so the question was, is there a way to change the style of the chart, the colors of the axis labels and things like that? I have a section on that in the 8th notebook later this afternoon. Lost my mic. At the rate we're going, we might not get there, but the information is there for you. The other thing I wanted to mention on that is there's an active pull request right now where people are trying to create a dark theme for Altair. So you could do, you could enable a dark theme and then it would work. We're just not quite there yet. Let's see. So yeah, so we talked about these data types, and I was going to do this as an exercise, but I think I'm gonna skip over this, and you can play around with the data types at another point. So we have about 15 or 20 minutes before our 3 o'clock break, and if we're late for the break, the food runs out. So my goal is to get us to finish right at 3 o'clock. So let's go back to this index, and there are a couple more things that I wanted to do before the break. So we've talked about the simple charts, these core concepts. Now I want to dive really quickly into binning and aggregation. We haven't done this yet, I believe. So again, we have the importing Altair at the top. I'm gonna use the cars data set again because we're familiar with it. Now, one thing that's interesting in Altair is we talked about in the beginning how the components of the grammar of graphics start with data, then there's transformation, and then there's marks and encoding. So this transformation thing that happens in Altair is actually, like, if any of you have used SQL or if you've used group by and pandas, the render does this kind of like data grouping and transformations automatically. So this is a visual representation of the group by operation, kind of a split, apply, combine. This comes from my my O'Reilly book, which, if you're interested, on Saturday morning, you can get a signed copy from the O'Reilly booth, so you should come by. But this is talking about split, apply, combine. So the idea here is that sometimes you have a data set with keys, and you want to split the data based on that key value. So we've split it into A's, B's, and C's. Then we want to apply some aggregate. Here it might be a sum, where we sum all the values within those categories, and then we combine it back together into one data set. So this is a fundamental operation in data analytics and when you're doing SQL databases or Pandas data workflows. And this is built into Altair whenever you use an aggregate. So for example, how you implement this in Pandas, you can take the cars data, you can group by some value, you can choose some value that you want to extract, and then take the mean of that value. And we see here that this Pandas group by operation tells us the mean of the miles per gallon in Europe is 27, in Japan it's 30, and in the USA it's 20. So this same group by operation here happens when we do y equals origin and we ask for the mean of the miles per gallon there. So the way to think about what's going on here is that whenever you specify an encoding, like if I said just y equals origin right here, that's kind of grouping the data, right? It's taking all the values of the data in the origin column and grouping them between here. And here it's actually drawing just one bar per set of grouping. And you can do things like you can do x equals miles per gallon, and you know that will I think I need to do something x equals miles per gallon. It's not doing mean. What's happening here? Is it automatically computing? Oh no, this is doing like a sum, or you know what it's doing? It's plotting everything on top of each other. So I might need to do something like color equals miles per gallon. Yeah. And I forgot a comma. So this is what it's doing. It's like plotting all the data on top of each other, and you're seeing the stack of them there. But if you want to actually group that and do an aggregation, when I say x equals mean miles per gallon, it's taking everything in this origin category and computing the mean of the miles per gallon. Yeah, you could do something similar, like for example, if I do y equals cylinders, and I'm going to tell it that it's an ordinal type, and I do row equals origin. I always forget my commas. Now we get a stacked chart where we're seeing it's a little bit easier to see if we also do color equals origin. Now we're getting a stacked chart where it's basically grouping by cylinders and by origin, and then within each of those groups, it's taking the mean of the miles per gallon. So it's useful to think about these aggregation functions in terms of group by that you would use in SQL or in Pandas if you're familiar with that kind of thing. And think about whenever you're doing these sorts of encodings, this is what's going on under the hood. This is a data transformation layer that's actually doing some sophisticated things. So what we can do with these binnings, as we saw before, we can do we can create histograms. So here I'm doing miles per gallon, and I've sort of switched a little bit here. You know, we saw before that we can do x equals this and y equals this to get bins and to get counts. Altair has this little shortcut for in the encodings. If you just pass an Altair encoding class, it knows how to relate it to the right encoding keyword. So here we've taken the miles per gallon and the origin, and we've grouped by that, and then we've taken the count within each of those, and it turns into a stacked bar chart, right? So does that kind of make sense, that how under the hood it's doing this group by, and you're implicitly specifying these group by keys by doing encodings. And then in the encodings, you can do the mean of a third value, or you can do the count, or you can do anything along those lines. Yeah, question. Yeah. So the question was how you would choose the opacity. The easiest way is just to do opacity here equals 0.5. Yeah, so it's a good question. There are actually multiple places that you can change the opacity, and we'll go into that more in detail in this configuration later on. But the easiest place is if you look in these mark settings. So like alt.chart.mark bar, and I'm going to press Shift Tab in the notebook to get the signature, and you can see all the different mark settings that can be done there. So fill opacity. Limit line, and you can read about what all these different things do as well. Yeah, if you do Shift Tab within a function name, you should be able to get that. Yeah. Cool. So one of the nice things about this, so look what we did right here. We had this x equals miles per gallon, y equals color, or sorry, y is count and color is origin. If we change these around a little bit, like we say that the x is the origin and the color equals the miles per gallon, then we get I'm gonna do x equals count and y equals origin. Then we get basically the same data, but we're looking at a completely different view of this. And this is, I love this symmetry here, right? Because all I did was take this chart, the stacked histogram, and change what things are being encoded. And you get this fundamentally different view of the data. And similarly, if I copy this down here, and I say instead that I want the I'm looking at this one right here. If I'm gonna just replace this right here, and I'm gonna, instead of the color being the miles per gallon, I'm gonna do the x equals the miles per gallon, and the y equals the origin, and the color equals the count. Now you get a heat map. And if you wanna change how the binning works, you can do alt.bin and say like max bins equals 20. And then you get a nice heat map. So again, this is the same encodings, but we've just the same values of the data, but we've cycled the encodings a little bit, and we get this fundamentally different view of the same exact data. And again, I keep pushing. I love this declarative approach, and this is another reason I love the declarative approach, is because a stacked bar chart is not fundamentally different than a sideways bar chart, and is not fundamentally different than a heat map. It's all the same values. You're just cycling the encodings. So you shouldn't have to do Altair.heatmap to get this, and Altair.histogram to do this, and Altair.stackedbar to do that. It should be part of your grammar, right? Am I convincing you? I feel like I'm like knocking on your door and saying, let me tell you about declarative visualization. Yeah, so other things you can do with binning. So here, for example, I'm going to do x as a year, and color as origin, and y as miles per gallon. So what does this tell us? This shows us over time the miles per gallon of cars that have been reported are sort of going up, right? We can kind of squint and see that they're going up. But this data is kind of on top of each other. It'd be nice to be able to see something a little bit more more easy to grasp here, because it's all layered on top of each other. So what if we take this, and instead of miles per gallon, we do mean of miles per gallon. Now again, what this is doing is it's grouping by the x value, the year, and grouping by the origin, and then within each of those categories doing miles per gallon. So we get single points in each category there. And now, since points are not really useful here, so let's do lines, and we can see a little bit more of the trend, right? So there's the trend of miles per gallon over the course of time, and we can see it's all getting better. This is relatively old data. It only goes to I don't know what it is, like late 90s or something like that. It was getting better, but USA is consistently behind Europe and Japan. But again, we don't, this doesn't tell the whole story, right? Because we'd like to see kind of the spread of the data. So another aggregate that we could do, and I'm just going to run this down here, we can do the year, and the color is the origin. And we can say that we want y equals the 0th confidence interval, and y2 equals the 1th confidence interval, the first confidence interval, and do an area mark. And then we get a aggregate chart that has two of these aggregates, and we can kind of see the spread of these miles per gallon over time. Yeah, question back there. Oh, cool. So instead of miles per gallon, you did. Oh, yeah. Yeah. Okay. So displacement is going down, and we can see horsepower. That's kind of going down as well. Yeah, and so you could then imagine. Oh, did you put multiple plots side by side to see that? Yeah. So that's anticipating the next section, the layering and stacking, where we dive into that a little bit more. But yeah, so you could imagine taking something like this. Actually, we'll just do this and say miles per gallon, and let's see. And I just want to do these together, right? So I'm going to do the shortcut that way. So we got the top one and the bottom one with the miles per gallon and the horsepower. We could even, like, if we wanted to stack them, it might be hard to see what's going on, but we could stack them on top of each other. Yeah, the scales aren't really great there. It's trying to put these on dual scales. So we could. This is getting beyond what I wanted to talk about. But we could do resolve axis x equals independent. So now we have two independent axes. No, x equals. Oh, y equals independent. Yeah, that's what we want. So now we have dual axes with these two things. Yeah, it's still the same. Why is it? I don't know why it's doing that. Anyway, you can start playing around with those things if you like. So one more thing I want to say about binnings. There's a special type of binning that Altair knows how to do, which is time binnings. So often you have data that's a time series, and you want to look at, say, monthly trends or daily trends or annual trends or things like that. And the way you can do that is with these binnings. So I'm going to take a look at this temperature data. So what this data is it's temperatures in Seattle in the whole year of 2010 every hour, right? So we have a lot of different temperatures. We have a date versus a temperature, really simple plot. And if we try to execute this, we get, oh no, max rows error, right? So just a little aside about what's going on here. As we saw, every time you run an Altair chart, it takes the entire data set, converts it to JSON, and embeds it in your notebook. So if you have a large data set with like 10,000 rows, and you make 6 charts, you've embedded 6 copies of those 10,000 rows in your notebooks. And we found, working with intro data science students, that one of the biggest problems was that people didn't realize they were doing that and ended up crashing their browser because they'd play for an hour and make 100 plots with 10,000 points each, and eventually it didn't work. So we put in this max rows error. It's a little bit annoying, but it reminds you that you have to think about what you're doing when you have a big data set, because it's like literally putting this whole thing in your browser, right? So the length of our temperature data is 8,000 right here. So there are a couple different ways we can get around this. There's you can enable the transformer with max rows equals none, and that will turn off this check. And then you can embed as big a data sets as you want in your notebook and shoot yourself in the foot. Or you can do this thing where you enable the JSON transformer. And what this does is every time you run a chart, instead of embedding the data into the notebook, it saves that data to a temporary file and then references it by URL. So that means the notebook doesn't get big, but you can still render large data sets. So I'm going to do that right here. And if you look at, I'm going to open my file window right here. And now if I run this data set, the dictionary version, you can see that it's the data is this Altair data E20 whatever, and that data probably appeared somewhere in here, but it's yeah, there it is. So there's my temporary data set that it's putting up there. So now we can render this data. We get another copy of the data set there because we haven't figured out we haven't done any hashing on it yet, and you end up with this ridiculous visualization. It's just a line going up and down every day for 365 days. So what if we want to see what the daily temperatures here are, or the monthly temperatures? The special binning type that is built into Altair now is this time unit thing. So if we say that we want the x to be the date, and we want it binned by the time unit of month, and then the y to be the temperature, this gives us the we've binned it and we've put all 30 points in each one, right? So now obviously we need some sort of aggregation. So here's a mean temperature and we've marked it with a bar. So this is a way that you can take that temporal data and kind of bin it, squish it down, and get some sort of interesting visualization there. The other thing that I like to do here, just to show you that this can be used in a kind of fun way, is if you take the date and you split it by the day of the month, end the month, and do that in x versus y, and then make the color the mean of the temperature, then you get a heat map across the year of January through December and date 1 through 30. And it shows you what the temperature, the mean of the temperature is on each day across the year. You can do the same kind of thing if you split it by a time unit of hours and months. Then we see what an average day looks like in January, pretty dreary, and what the average day looks like in July, where it gets pretty hot about 4 o'clock and then tapers off into there. So it's a way of, it's a more specialized way of binning your data for temporal data, for dates, so that you can pull out some interesting things. Okay, it is exactly 3 o'clock right now. We're going to take a, how long is the break supposed to be? 20 minutes? Does anyone know? Let me see. It just says the break is at 3 p.m. Let's call it 20 minutes. So be back in here at 3:20, and we'll take a look at applying some of these things to some interesting data sets. Thanks. Right, welcome back in. So at this point, I've been like talking at you for about an hour and a half, and I'm tired of hearing myself talk. So what we're gonna do, and what I want you to do now is grab someone next to you, or a 2 or a 3 person team, and I want you to consult together and figure out what data set you're going to explore. So here's our Exploring a Dataset section. If you click on that, I have 3 examples here from the Vega datasets. So one is Seattle weather. This is interesting because you have dates between 2012 and 2015. It gives the precipitation, the minimum and maximum temperature, the wind speed, and the weather type. So you can start thinking about how you might create various kinds of charts with that. Gapminder data, this is interesting. This is like worldwide data on fertility rates and life expectancy over the course of many years and many countries. So you can think about all the different encodings you would do with that and the ways you might explore that. The population data, this is US Census data starting in 1850 that give the number of people as a function of age range and gender or sex. And then finally this movie data, this is fun. It has a whole bunch of different data about movies, including everything from the year to the rating, whether it's R or PG-13 or things like that. But the most interesting thing is this has the IMDb rating, and it has somewhere in here the Rotten Tomatoes rating. So you can start looking at how movies fare on those 2 websites based on when they were released, or based on how much they made, or those sorts of things. So these are 4 data sets that I'd suggest. If you have another data set you want to explore, feel free to do that. But I'd like to give you about a half an hour or so to actually try out some of these concepts. And as you do this, think about what marks you can use that we've seen. Think about the encodings that you can use. Think about the aggregations. Look, I even got a link to the list of aggregations, since you asked that earlier. And things like stacking and layering, where you're doing layer, concatenation, vconcat, and stuff like that. So I want to give you some time to try this out and choose one of those data sets and run with it and see what kinds of visualizations you can make. And I'll be available to answer any questions while you're doing that. So we'll do that until about, say, 3:50 or so. All right. Wanted to mention one thing really quickly. Some of the data sets on there are like local as part of the installation, and you don't need a web connection. Others, like the Gapminder data set, actually needs to download. So if there are web connectivity problems, you might not get it. So the Seattle weather one is the safest to use if you have web connection issues. All right, so we got to the end of our little exercise time. This I almost didn't want to come back up here because it seems like everyone is having fun trying these things out. It's really cool to see the kinds of progress people are making. But we do have some more things to cover and some more details that I think will help you make even better charts. I've had a lot of people ask me questions, and I said, okay, that's in notebook number 6, notebook number 7. So why don't we dive into that a little bit? And does anyone know what's the official end time for us today? 4:40. Oh my goodness, that's like no time at all. Okay. So the things that I want to get into, a few of these things. We probably won't have time to do all of these, but in particular, I really want to get into this selections thing because we've sort of scratched the surface of what you can do with selections. And to me, this is one of the things that's really, really incredible about Altair. I mean, most of this stuff I could do in other plotting libraries, but I don't feel like I can do the selection things in other plotting libraries. So I want to get into that right now. And then just to give you an overview of some of the other topics that we may or may not get to. Transformations, so this is a way you can actually affect data streams within the charts. So we've seen the bin transformations and the aggregate transformations. And there are also other ways to do more general transforms on your data within the chart spec. So we'll talk about that in a little bit. There's configuration, so this is things like adjusting axis limits, formats for titles and for tick marks and things like that. And so you can pretty much adjust any aspect of your plot that you'd like to. And then finally, there's geographic charts. So Altair has the facility to do geographic markers like choropleth plots across the United States where you're coloring the shape of the state based on some value for the state, that sort of thing. I want to say that the geographic stuff is not it's not totally mature yet. This is one of the newer pieces of Vega-Lite, and I imagine over the next several months, as Vega-Lite makes that piece more mature, we'll get those pieces into Altair as well. And and that'll get to the end when we can return to these visualizations you're making and apply some of these ideas that we'll cover in the second half. So without further ado, let's click on the notebook 6, the selections, and take a look at this. So far, mostly what we have seen, unless you've gone ahead and explored some more yourself, mostly what we've seen is the interval selection. But there are two other fundamental selection types in Altair. There's the single selection, and you can think about this as like if you have a bar chart and you want to point and click on an individual bar and get that data. That's what the single selection does. And then the multi-selection is like a single selection, except it allows you to toggle, to point and click sets of data and to toggle them on and off. So we'll see examples of that. And then as far as what you can do with these selections, we've seen this conditional encoding. So where you say the color should be the origin within the selection, or it should be grayed out otherwise. But you can also bind to scales and domains, and I'll show you that. And you can also filter data. So this, I think we actually saw a filter example too with earlier on. But so I want to dive into these combinations, and again, you should think of these as like building blocks from which you can create more complicated charts. You don't have to develop a custom interaction from the ground up. You can use these building blocks, put them together, and create some really cool things. Get one of what out of order? Yeah. So that's a good point. So he was asking about he has a dark display, so he wanted to configure his chart so the background would be white. And the configuration is the one method in there, I believe, that has to happen at the very top level of the chart. It has to happen kind of last in your specification. These things you should be able to do these anywhere within the chart. Okay, so basic interactions. What did I not do? I forgot to import something. Yeah, right there. You always got to run your code. There you go. So we go back to the cars data. I'm nice and familiar with that. The basic interactions we saw is that you can do this .interactive, right? And you can do a tooltip with any column of the data to get tooltips on top of it. So we're scrolling, scanning, doing tooltips. So this is really nice, but this interactive right here is a shortcut to something that's a little more sophisticated going on under the hood in the chart, and I'll show you what that is. But as we saw, the basic type of selection that you can do is this interval selection. And again, this is just repeating what I did in that live demo, but I wanted to talk through it a little more carefully now so that hopefully sinks in a little bit. So you have this, if you have a scatter plot like this, in order to create a selection object, we run this line of code, alt.selectionInterval, and oops, that's something I was trying earlier. So if you look at this selection function, if you do selection underscore and then tab, you can see that there are these three kinds of selections that I mentioned: interval, multi, and single. And if you look at interval and you press open close parentheses and then shift tab in the notebook, it gives you the signature. And you can see that there are a lot of various ways you can control the way this interval works. So there's this bind thing, there's empty, there's encodings, there's fields, mark, on, resolve, all these different things. So just to show you what a few of these do, if I execute this code right now, by default you have an interval that you can drag and you can translate around. If you want to change this a little bit, you can do something like translate equals false and run that. And at this point, if you draw the interval and you try to click and drag, it'll go away. So the translate equals true and translate equals false is what lets you click and drag that interval once it's around there. And similarly, if I scroll on this, I can zoom in and out. And again, if you do zoom in here equals false, then you'll see that no longer works and you can no longer zoom on it. So these are the kind of ways that you can you can modify these intervals. As we also saw with the selection interval, if you just say encodings equals X, that means you can just select on the X-axis. If you say encodings equals Y, you can select on the Y-axis. So these are the types of things that you can do to change this. But no matter what type of interval you choose, no matter what user interactions it is, what's going on is that when you select the data within this range, it's providing a signal in the front end, in the front end renderer. And so under the hood, if you were watching in the JavaScript and you knew what signal to look for, you could create a JavaScript callback that would do something with that signal once the selection changes. And so that's a little bit low level. On the Python side, we don't have to really worry about that, except that we can use these. We can use things like the condition to say when the interval changes, I want things inside the interval to be origin, and I want things outside the interval to be light gray. Right. So this is how you should think about these things, how they're working. And it's nice that JavaScript side of things is kind of abstracted away in the Python grammar, because I don't know about you, but I don't like writing JavaScript. So yeah, we saw. I mentioned a little bit about this above. You can customize the interval by doing encodings as X. You can customize it with encodings equals Y. And another interesting one is this selection interval, this empty command. So if you say empty equals none, this says that when there's no interval at all, when there's no selection and the selection is empty, it treats none of the points as being in the selection. So this is nice because you can, by default, have them all turned off. And if you do the empty equals all here, this is the behavior that happens if you don't specify anything. Then when there's no selection, it colors them all. Right, so this is just to show you that as you dig into how these intervals work and how these selections work, you can do a lot of different ways to control exactly what's going on with the interaction there. Okay, so that's the interval selection. Let's take a look at the selection single. So what does selection single do? Here I made the circle size a little bit bigger just so they're easier to click on. And again, I made the color conditional on this single selection. And if it's in the selection, it's origin. If it's out, it's light gray. So what does this do? Single selection means you can click on points and highlight them. And you can do interesting things with that. And if you click off the points, then they all highlight again because the empty one is everything. Empty here is all by default. We can change this to other types of behavior too. We can say we want, instead of on click, we might want the behavior to happen on mouse over. And we might want it to happen not when we're exactly on the thing, but happen with the nearest point. And if we do that, then we move around, and as I'm moving the mouse, the selection updates. So you can imagine doing things like this. Actually, I might. No, I'm not going to do that right now. You can imagine doing things like this, like controlling the size of the point when something's hovering over it, or you could. Actually, this is fun enough that I'm just going to do this right now. Points. So we could do something like text equals alt.chartCars.markText. We haven't seen this before. And we could do let's encode the X and Y as horsepower. And I'm going to do the text encoding equals, what should I do? The name. And if we do points plus text, plus is an operator to layer them on top of each other. So now you get this ridiculous thing, right? Like you have all the names on there just plotted there. But what we could do here, if we wanted to, we could say opacity equals alt.condition. And if it's in the single selection, then it should be alt.value 1.0. But if it's outside that selection, we want the opacity to be 0, so you can't see it. So let's see if that works. No, it didn't work. What did I do wrong? Oh, yeah. Right. So, and I'm also going to do here, because I did that wrong, let's do empty equals none. So that, empty equals none. There. So now, oh man. So now I highlight over it, and this crazy thing is happening is that every time I highlight, it's like putting everything there, right? As I highlight over it. So this is the funny thing with these selections. What we want this single selection to do is we want the encodings to be X and Y. I believe that's what we want. Did that do it? Yeah. So what I'm saying here is that I want what this encodings lets you specify is when you have the selection, it'll say whatever data contains the same value of these encodings as the point in the selection will be part of the selection. So previously I think it was selecting on color or something like that, but I'm saying that I actually want to trigger on the X and Y value of the selection. So when I hover over a point, it says, here's the X and Y value of this selected point. Let me find all the other things that have that same X and Y value, and then highlight them. And so now we have this, and this is a little bit, I don't know if I really like the way that that's centered over the point right there. So there's, in mark text, I can do dx equals 50. I think that'll do it. And that basically says that I want the X value to be shifted by 60 pixels from the origin. So now we have this nice little basically like tooltips. What's that? Yeah, it's the center. I think we could actually do here align equals left. Does that do it? Yeah, so now it's like way too far away. I should have done that at the first. So let's do dx equals 10 and align equals left. So now it starts 10 pixels over. So this is a way that you can do. We could do something like this with tooltips, right? But it's a way to basically shows you the power of these sorts of single selections. Now we're hovering over points and making things appear. Yeah. Yeah, good point. So here's some overlapping points. So they have the same x and y value, and because we're triggering on x and y, then so I wonder what happens. I've actually have never tried this before, but I wonder what happens if we trigger on name. Is that gonna? Yeah. Oh, that's not an encoding. Sorry, that's a field name. What if we trigger on text? So it'll that didn't do what we wanted. So okay, so the funny thing about Altair is because in developing this package, I basically wrote a Python wrapper for this Vega-Lite grammar. When I finally finished the Python wrapper, it was a Python package that no one in the world knew how to use. Because a lot of it was auto-generated. So the funny thing about this is I'm still learning a lot about this API, and if you ask me who knows how to do it, I would say nobody. But anyway, so you can experiment and learn these things along with me. But I'll stop live coding things that I didn't plan. Okay, so that's the single selection. The last type of selection that we have is this multi-selection. It's very similar to the single one, except you can press the shift key and start selecting multiple points and like toggle points on and off. So I don't know, that can be useful, right? That you could imagine doing something with that. It's a nice primitive to work with. And just like with the single selection, you can make it do on mouse over and nearest equals true. And this one is kind of funny. Like, if you just move your mouse around, you get 1 point just like above. But if you hold the shift key while you move the mouse around, you can like paint them all. And it's a really cool trick to try to get all of them to turn on because they toggle when you go back over them. So, like, I feel like when my kids get proficient with computers, I'm going to give them this and just say like, make all the points colored. They'll be there for hours. So those are the three basic selection types, and we've shown them mostly with points here, but you can imagine using them with bars, with areas, with any of the types of marks that are out there, and particularly the clicking ones, the single and the multi are nice for bar charts. Yeah. Mm-hmm. Yeah, maybe. Let's. Yeah. So 2 questions. I'll answer the easy one first. The first questions was, can you click on the legend and select points that way? Currently, no, but that's there's an open issue on Vega-Lite, and I think they're going to tackle that soon, because it's a commonly requested feature from people who use Plotly or NVD3 or some of these other things. The second question was, can you click on a point and select everything of the same color? And I think you can. I think if you just do encodings equals color, I believe that will work, but I hope, yeah. So basically what I'm saying there is I have a single selection, and I want to trigger on everything that has the same color as the point that's being selected. Yeah. Yeah, so we could do, I was going to get to this in a second, but you could do this. interactive mode, where you zoom around and then you click and select. So there's no limit to the number of selection operators you can put on a single chart. Yeah, so the same question with currently you can't select on the legends, but that's something that we're hoping to get in there soon. Yeah. Okay, so selection. So far we've mostly seen, as far as what you do with selections. So far what we've mostly seen is conditioning encodings on it, so changing the color, changing the opacity, things like that. But there are other things that you can do with selections. You can bind the selections to various things, and currently the only binding you can do is scales. So this is an interval selection, and we're saying that we're going to take the extent of that selection and bind it to the scales of the chart. What do you think that'll do? Yeah, so you said resize. So exactly, if I change the size of the selection, it changes the size of the scales on the chart, right? So this is actually, when we do that dot interactive, that's a shortcut to exactly this. That's a shortcut to adding a property that is adding an interval selection to your chart where the edges of the interval are bound to the scales of the chart. So it's a little bit weird way of thinking about it, right? But imagine like if I delete that and I'm drawing this selection and I move it around, right? It's moving the chart, and if I zoom, it makes it smaller and bigger. So by making the chart extents the same size as the selection, that gives us that interactivity. So yeah, you can play games like that. Right, yeah, you can do that kind of thing. I'm not confident enough to live code that right now, but there are a lot. If you dig into this selection architecture, and the documentation is not there on the Altair website, but if you go to the Vega-Lite website and look at all their selection information, you can do a lot of those kind of things. He was asking about selecting points and then having it like trigger a resize of the plot. I believe you can do that sort of thing. Yeah, it's cool because the building blocks are flexible enough that you can do a lot of applications with them. So that's one thing you can do. You can bind the scales on one plot. The other thing you can do is actually bind scales on different panels. So here's an example of the weather data. How many of you were working with the weather data during our time? Oh, about a third or so. Yeah, so the weather data is interesting. This is Seattle weather from 2012 to 2015. I'm plotting the min and max temp with a little line between them and coloring it by the type of weather. So you can see that it's sunny here and it's rainy there in the wintertime and cold, sunny and warm in the summer. But one thing we can do with selections here is we can bind our selection to the domain of another panel. So let me do an example of that. If we stack two versions of this, I'm going to take the chart and do an 800 by 300 version on top and an 800 by 50 version on the bottom. So we have the same data just stacked on top of each other, right? And I made it kind of wide here. Now let's add a selection to this bottom chart that if we drag on the x-axis, it will change the x-axis domain on the top chart. And this is easier than it sounds. So we're going to create an interval selection with encodings equals x. So it just works just as on the x-axis. We're going to bind that selection to, or we're going to add that selection to this where are we? Sorry. We're going to add that selection to the view chart on the bottom that's a height of 50. And we're going to make the x have a scale with a domain associated with that interval on the top. All right, so this it gets a little bit complicated, but now what happens is if we drag here, we get a zoomed in view on the top. So if we want to know what was going on in January 2013, we can see the zoomed in version of that and get the daily data. So this, I really like this because it's a way of creating dashboards that allow you to really do some dynamic things. You mean to have a default selection? No. So currently there's not a way to say like the selection by default should have some value. That's been a question that's come up a couple times. It's not currently on the roadmap, but if you have a really compelling reason for doing that, you should raise an issue on the Altair GitHub repository, and just so we can. Oh yeah, that would be good. So like if this were the default or something, and then you'd start sliding it along. Yeah. Yeah, that's a good idea. I'm not sure. You'd have to think about some way for the grammar of the chart to express the state of the selection. So it'd be a little bit delicate to think about how to work that into the grammar without making it flexible enough. But yeah, it's worth thinking about it. Okay, so what's that? No, you wouldn't. The state of the selection is not saved with the chart, unfortunately. I hadn't actually thought about that. That's a little counterintuitive. You would think that if you click save on a chart, it would save what you see. Yeah, some sort of snapshot thing. That's a good idea. And you should all like start developing Altair. You have great ideas. Okay, so we saw conditioning encodings on selections. We saw binding selections to domains. We saw binding selections to domains on other panels. The last thing you can do that's interesting is filtering. And I'll gloss over this pretty quickly because we saw something similar. So basically, if you have a selection interval, we're going to add it to our scatter chart. So we're selecting points on the scatter chart. We're conditioning the color of the scatter chart on that selection. So points within the selection will be colored, points outside will be light gray. And then we'll have a histogram on the bottom, and that histogram is made up of data that's filtered on that selection. We haven't gotten to transforms yet, but I have a whole notebook on transforms later in this tutorial. But so we're going to filter the bottom data on the elements of that selection, and that lets us do this thing where we have a summary histogram on the bottom of what's inside this selection on the top. Yeah, so lots of different things you can do there. And similarly, we could, if we have this same plot, let's change the selection a little bit. Let's, instead of an interval selection, let's do a multi-selection that triggers on color. And we'll filter the scatter points by this click selection. And we'll apply this click selection to the bar chart. And we'll condition the bar chart's color on that click so that it's the origin if it's selected and it's light gray if it's not. So now this means we can click here and see parts of the chart up above. Yeah, so this is your legend. Yeah, exactly. Yeah, so you'd need, how could you do that? So this would be interesting. You do, yeah, so if I do alt.color origin and legend equals none. So I think that should do what you want there. Oh, there's still a legend from the bottom one too. No, I did something wrong. This is not working as easily as I thought it would be. Oh, really? No, it's a schema validation thing. So there's something weird with the conditions. You keep asking questions that I try to live code on something I can't do. Okay, so I got rid of the legend by doing no legend on the top and the bottom. And now I'm gonna stack this sideways, and I'm gonna take away the count. And I'm going to actually do mark points. Uh, yeah. Yeah, so now we have a clickable legend. Yeah, yeah. I like how you think. That's great. That's a good hack. I should add that to the tutorial. That's nice. All right, so anyway, with selections. Yeah, so just in summary, we have the 3 types of selections you can use. We have the basically 4 things you can do with those selections at this point. I don't think there's anything else in the Vega spec that you can do with the selections at the moment. But I want to, again, we have about 25 minutes left. And you know, I think rather than talking at you for the next 20 minutes, I think what I'd like to let you do is take those charts you were working on a few moments ago and start playing around with these selections and see what sort of things you can do with this selection grammar, these available selections, the things you can do with them. And I think you'll, in my experience, like sitting down and playing around with code for half an hour is way better than hearing someone talk about code as far as like getting it into your mind and remembering what you're doing. So I'm going to let you do that, and that'll take us out to the end of the tutorial at about 4:50. 4:40. Okay, so we have like 17 minutes to learn all about selections. So ready, set, go. Oh yeah, clickable legend. So let me make it a little bit smaller so you can see everything. Maybe a little bit bigger so you can read it. There's the clickable legend hack. Yeah. All right, so we are just about out of time, everyone. I just wanted to mention that if you want to learn more about this, I have more notebooks that we didn't quite get to today, so you can try out some things. Also, the website, the Altair website, is a great place to look. And if you come up with interesting examples that are not on the website, we'd love to have your contributions. Like if you look at the examples on the website, probably 3/4 of those were written by other people other than me, who just like found an interesting chart they could make with the data. And it's a great way to get involved with the project if you're interested in it. Otherwise, I'll stick around afterwards to answer any further questions you have, and thanks so much for spending the afternoon with me. This was fun.